Your machine learning model has been built and evaluated, and now it's ready for production. So let's take a look at our deployment options. Machine learning model deployment can be categorized into three broad areas. Firstly, there is real-time inference, and this involves hosting a machine learning model as an endpoint on a web server, and applications can then provide data via HTTPS and receive back in a short period of time the predictions of the model. And secondly, you have batch inference, where on a regular basis, triggered by time or events such as data landing in a data lake, resources are spun up and a machine learning model is deployed to make predictions on new data that is now available in the data store or data lake. And thirdly, we have models that are deployed on the edge. And instead of requiring input data to be passed to a backend, the model prediction is computed on the edge device. And think of IoT or Internet of Things and web applications for these type of edge deployments. So how do you decide which method to use? Well, there are several factors that need to be taken into consideration. Firstly, latency. How quickly does the application or user require the results of your model's prediction? And secondly, data privacy. Are there any issues or concerns of sending data to a backend? And thirdly, you have to consider network connectivity. Some deployment options require access to the internet or to the network. And if the environment in which the model needs to be deployed has limited or no internet or network connectivity, the options available to you are limited. And fourthly, you have to also consider cost. Certain deployment options will be more costly than others. And think about having a server that is online 24/7 to serve predictions. So what will be the cost to operate and maintain the server? So let's look at each consideration in more detail, starting with latency. Imagine that you've created a web or mobile application that provides a machine learning service that yields predictions based on a user's input. It would be a better user experience if the user was able to obtain the results of the model shortly after providing some input, rather than waiting several hours. In this particular instance, deploying the machine learning model in a real-time inference pipeline or in an edge deployment would be ideal. On the other hand, if the machine learning model is being used to enrich some data as part of a data pipeline, and the data is not required to be available immediately, and perhaps new data only arrives once a day, it would be more cost-effective to predict the new input data using a batch inference pipeline. The second consideration is data privacy. Sometimes when you're doing real-time predictions or batch predictions, your model itself might be hosted by a third party. And in this instance, if you have to share personal information or personally identifiable information to that third party, there may be some constraints that you face. To get around data privacy concerns, you may choose to deploy the models onto edge devices. And this will then require the edge devices to have sufficient computing power to actually host the model and do the calculations required to predict on the input data at the edge. And so in this instance, the data is not passed to a server that is hosted on the cloud. Rather, all the predictions and the model itself is hosted locally on the device. And the drawdown of deploying onto edge devices is that typically the amount of compute resources is a constraint, and as a result, the choice of model architecture may need to be more simple in order to save on resources, which may in turn lead to a performance drop in the model's predictive power. All right, the third consideration is network connectivity. When deploying a model to support real-time predictions or batch predictions, you would require some form of network connectivity capable of transmitting input data from the source to the backend. However, if the source of input data has limited or no network connectivity, it may mean that in order to solve the use case, the model would need to be deployed closer to the source of the data, and so you would consider edge deployments. And the final factor is cost. Certain methods of deployment will result in greater costs. When deploying for real-time predictions, you will require the endpoint to be available 24/7, and in addition, you may need to scale up the compute resources during heavy load periods and scale down during low load periods. And this management of scaling up and down will potentially also require a team to manage the real-time infrastructure. On the other hand, batch-based predictions are generally cheaper as you only need to spin up the resources for the time required to predict on the new batch of data. And the amount of resources that you would have to utilize would depend on the volume of data as well as how quickly you need the model to predict on that data. But in terms of operational cost, edge deployments may be the cheapest option yet, as you're utilizing the resources of the edge device, but the cost may be more indirect. And this includes the cost of potentially deploying an inferior model into production that has lower predictive power than other models, and also the cost of managing the deployment of models to a fleet of edge devices, and the cost of evaluating the performance of the model on the edge. All right, our next lesson will focus on model monitoring, where once you've deployed the model, we will look at the checklist of things that you need to take into consideration to ensure that your model is performing well. So I'll see you soon in the next lesson. Bye for now.